You know that Sombrero Galaxy? It's always been one of those classic astronomy pictures for me. Like you see it in every textbook, that perfect spiral, almost edge-on.
Right.
But the James Webb Space Telescope, it's uh, it's really giving us a whole new view. I mean, it's like suddenly having these high-powered infrared goggles.
Yeah, the exciting thing is the JWST can study things we could barely even detect before.
Yeah.
Like the sombrero's dust.
Dust.
Yeah, we're seeing it in detail like we never have before. And, well, it's really telling us a story,
Yeah.
like about how the whole galaxy works.
Okay, I admit, dust doesn't usually get me too fired up, but I have a feeling there's got to be more to it, right, than just dust.
Absolutely. You see, with the JWST, this mid-infrared image, it's not just showing us where the dust is. It's showing us how it's spread out.
Okay.
And it's not just like a smooth sheet or anything. It's
Oh.
clumpy. Yeah, concentrated in certain spots. And that's what tells us something really important.
What's that?
Those clumps. Those are the hot spots for star formation.
So it's not like the dust itself is making the stars, but it's like a sign, a clue of where all the action is.
Exactly. Think of it like this. Here on Earth, you see a construction site. There's going to be a bunch of dust kicked up.
Right.
It's the same idea in a galaxy. When stars are forming, all that gas and energy smashing together, it just creates these dusty environments.
I see, yeah.
And what's even more interesting, the JWST, it can actually detect specific molecules inside these dust clouds.
Hold on, wait. We're talking about figuring out what, like, specific chemicals are in space dust that's millions of light years away?
Yeah, you got it.
Wow.
Things like polycyclic aromatic hydrocarbons.
Okay.
They're these carbon-rich molecules. It's not just random dust particles. These things are actually, they have a role in the whole chemistry of star formation.
That's amazing. It's like cosmic forensics or something.
Yeah.
Figuring out what a galaxy is doing just by like analyzing its dust. So given all this dust and activity, I'm guessing the Sombrero Galaxy must be like a star-making machine then, right?
That's where things get a little interesting. Even though it's got all these dusty nurseries, compared to other galaxies that the JWST has looked at, the Sombrero Galaxy is actually, well, it's kind of laid back when it comes to making stars. Like it's forming less than 1 solar mass of new stars each year.
Less than 1. Wow, okay. So for comparison, like our Milky Way, how many stars does it churn out each year?
The Milky Way is a bit more of an overachiever. It makes about 2 solar masses of stars per year.
2? Wow, okay, so the Sombrero, even though it looks so bright and active in those pictures, it's more like a slow burn when it comes to new stars, huh?
Exactly. It's a good reminder that what we see in one kind of light, like visible light, might tell a very different story when we look in another. And the JWST, that's what it's all about, showing us those hidden layers.
Okay, so we've got dust, we've got stars being born at a surprisingly slow pace, but I know what you're thinking. No galaxy would be complete without a supermassive black hole at its heart, right?
You're absolutely right. And the Sombrero Galaxy, it doesn't disappoint.
Right.
It's got a monster in the middle, a black hole, billions of times the mass of our sun.
Wow.
But here's the thing. It's actually pretty quiet.
Quiet. How can something that massive be quiet? I mean, I'm imagining a cosmic vacuum cleaner just sucking everything in and creating chaos.
Well, it is pulling in stuff, don't get me wrong.
Mm-hmm.
But it's not as dramatic as some of the others we see. Astronomers, they call it a low luminosity AGN. That's short for active galactic nucleus. So it's like it's kind of slowly sipping on the matter that falls into it instead of having this huge feast, where it blasts out these powerful jets of energy.
Okay.
It does have a small jet, but nothing compared to what we see in some other galaxies.
So more of a gentle giant then, instead of a raging beast.
Exactly. Think of it like this. Some black holes are like roaring, fire-breathing dragons, while this one, Sombrero's black hole, it's more like a giant that's sleeping, quietly radiating a little bit of energy as it slumbers.
Okay, I like that. So we've got these dusty nurseries, we've got a pretty chill star formation rate, and a surprisingly peaceful black hole. What else is this galaxy hiding?
Well, have you ever heard of globular clusters?
I think so. They're like groups of stars, right? I remember seeing pictures. They kind of look like swarms of fireflies.
Yeah, that's a good way to visualize it. They're these tightly packed groups of stars, like hundreds of thousands, sometimes millions of stars, all crammed together by gravity. And the incredible thing is, they're ancient. Some of the oldest structures in the universe.
Okay, so ancient star clusters. What makes them so interesting to astronomers, though? I mean, they just seem like pretty ornaments hanging around the galaxy.
Oh, they're way more than ornaments. They're like time capsules.
Yeah.
Because all the stars in a globular cluster formed at about the same time, billions of years ago. It's like having this lab to study how stars evolve. You have thousands, even millions, of stars all the same age but different sizes, all evolving together.
Oh, I see. So by comparing stars within a cluster, astronomers can get a better idea of how stars of different sizes, how they live and die.
You got it. And the Sombrero Galaxy just happens to be loaded with these globular clusters. We're talking about 2,000 of these stellar time capsules all orbiting around it.
2,000? Wow, that's a lot of data for astronomers to work with.
It really is. It's an amazing chance to dig into the history of this galaxy and how stars in general have evolved. And the James Webb, with its ability to see right through dust and pick up that infrared light, it's giving us the clearest picture of these clusters we've ever had.
This is incredible. We're not just seeing a pretty spiral anymore. It's like this multi-layered, complex view of the Sombrero Galaxy.
And there's more. The JWST image, it's not just about the Sombrero Galaxy itself. If you look closer, you can see tons of other galaxies in the background.
Oh, wow, yeah. It's like looking through a window into deep space.
And those colors you see in those background galaxies, they matter too. They can tell us how far away they are, how old they are, even what kind of stars they're made of.
So it's like a bonus peek into the whole vast universe, all in one image.
Exactly. The sombrero is our main subject. But behind it, there's this whole tapestry of the universe waiting to be explored.
I have to admit, this is way more fascinating than I thought it would be. But all of this info is coming from this telescope that's 1,000,000 miles away, right? Getting time on that thing must be like winning the lottery.
Oh, it's incredibly competitive. For the JWST's 4th year of operation, astronomers submitted something like 2,400 proposals. They were requesting a total of 78,000 hours of observation time.
Whoa. That's a lot of people wanting to use the JWST.
And there are only so many hours in a year, right?
Yeah.
So getting time on the James Webb is a really big deal.
So how do they decide who gets to use it?
Well, there's a whole process. It's called peer review. Basically, experts get together and they look at every proposal.
Okay.
They want to see which ones have the most potential for big discoveries, to really push the boundaries of what we know about the universe.
Got it. So it's not enough to just have a cool idea. You have to convince these other scientists that your research is worth that limited time on this incredible telescope.
Exactly.
So what are the hot topics? Like, what kind of research is in such high demand?
Well, the most popular requests are all about studying those distant galaxies, like the ones we see in the background of that sombrero image.
Makes sense. I mean, those distant galaxies, it's like looking back in time to the early universe.
Right. And then there's a huge amount of interest in exoplanets.
You mean those planets that are orbiting other stars? Are we trying to find alien life?
Well, the JWST, it's not quite set up to find life directly, but it can actually analyze the atmospheres of exoplanets, looking for signs of chemicals that might suggest good conditions for life.
Wow. So we're talking about potentially finding habitable worlds light years away.
That's the hope.
This is all so incredible. We've gone from thinking about the sombrero as just this pretty picture to realizing it's this whole complex system with the dust, the star formation, a surprisingly peaceful black hole, ancient star clusters, and even clues about the rest of the universe.
It's amazing, isn't it?
It really is. My brain is officially full. I think we need a moment to process all this.
Absolutely.
Oh.
Let's take a short break, and when we come back, we'll really dig into what all this means for our understanding of the universe.
Okay, so my mind is still kind of blown from everything we talked about in the first part, about the Sombrero Galaxy. It's amazing how much is actually going on in that seemingly simple spiral.
Yeah, it is. It really shows how the James Webb Space Telescope is changing the way we see the universe.
Right.
We're going way beyond just pretty pictures now. We're getting this incredible amount of information.
One thing that really stuck with me is this idea that the sombrero, it's kind of like a cosmic contradiction. Like it looks so active and vibrant in those visible light images, but then the JWST tells a different story.
That's a good point. It really does challenge our expectations, doesn't it? We tend to think that bright, well-defined features mean there's a ton of activity going on. But the sombrero is showing us there's a lot more to a galaxy than what we see at first glance.
So help me out here. In what ways is it a contradiction?
Well, think about what we said about star formation. The sombrero, it's actually forming stars at a way slower rate than our own Milky Way. But in those visible light pictures, that dust lane is so clear and the central bulge is so bright, you'd think it would be like a star factory.
Right, exactly. It's like those pictures are giving us a false impression of what's really happening inside the galaxy.
Exactly. And it's not just the star formation either. Even that supermassive black hole at the center, billions of times the mass of our sun, but it's surprisingly quiet. It's not shooting out these huge jets of energy like we see in other galaxies.
So maybe the takeaway here is that we can't judge a galaxy by its cover, so to speak.
Yeah, I think that's a good way to put it. The JWST is showing us that there's a whole hidden universe out there, stuff we just can't see with visible light alone. It's like we've been looking at a black and white photo, and now suddenly we're seeing it in full color.
And the Sombrero Galaxy is the perfect example of that.
Exactly. It shows us that galaxies are way more complex and interesting than we thought. They're not just a bunch of stars and gas. They're these dynamic systems with all these complicated processes happening at scales we're only starting to understand.
Okay, so we've talked about the dust, the stars, the black hole. What about those 2,000 globular clusters we mentioned? How do they fit into all of this? This idea of the sombrero being more than meets the eye.
The globular clusters, those are really fascinating because they give us this glimpse into the Sombrero Galaxy's past, like even beyond its own history. We're talking about the early universe.
Okay, break this down for me. Pretend I'm still trying to pass Astronomy 101.
Okay, so imagine each cluster as its own little mini galaxy. All the stars in a globular cluster. They were born around the same time, billions of years ago, from the same cloud of gas, and they've been stuck together by gravity ever since.
So if we study those stars, it's like we can travel back in time and see what stars were like way back then in the early universe.
That's exactly it. And since the Sombrero Galaxy has so many of these globular clusters, it gives us a ton of data to work with.
It's like having 2,000 windows into the past, all showing us different snapshots of the universe's history.
And remember, these clusters, they're incredibly dense. Hundreds of thousands, even millions of stars all packed in together. They're like perfect labs for studying how stars evolve.
So about this laboratory idea, what exactly are astronomers hoping to learn from these clusters?
By looking at different stars within the same cluster, we can see how stars of different masses change over time. It's like watching a time-lapse of a star aging, but all in one frame. We can learn about how long stars live, how they die, what they leave behind.
That's amazing. It's incredible that we can get so much information just from studying these ancient star clusters.
It is. And the JWST is making it possible to study them in even greater detail than ever before. Its infrared vision lets it see right through the dust that blocks our view of these clusters in visible light.
So we're getting a much clearer picture of these time capsules than ever before.
Exactly. It's completely changing the way we understand how stars evolve, and not just in the Sombrero Galaxy, but everywhere.
One thing we haven't really talked about is that amazing backdrop in the JWST image. All those distant galaxies in the background. It's like a reminder that there's a whole universe out there beyond just this one amazing galaxy.
It really puts things into perspective, doesn't it? The Sombrero is just one galaxy out of billions in the observable universe. And every single one of those background galaxies has its own unique story to tell, its own history, stars, planets.
It's almost too much to think about. So how do astronomers even start to study something that vast and complex?
Well, one way is by looking at the light coming from those galaxies. Remember how we talked about the color of a galaxy telling us about its distance, age, and what kinds of stars it has?
Right.
So even though those background galaxies look like tiny little dots, they're actually packed with information.
Wow.
And by studying them, we can learn about how galaxies have changed over billions of years, how they formed, how they interact with each other, even how the universe itself has changed.
I'm starting to see why astronomers are so excited about the James Webb Space Telescope. It's like it's given us this whole new way to see the universe.
It really is a game changer. And the Sombrero Galaxy is just one example of the incredible discoveries that are being made.
But let's be real, the JWST is a pretty hot commodity in the astronomy world. Getting time on that telescope must be insanely difficult.
Oh, it is. Like we talked about earlier, the demand for time on the JWST is way more than the time they actually have available. Astronomers from all over the world are competing to get a chance to use it.
So what does it take to win that competition?
Well, you have to have a really strong research proposal, one that tackles those big questions in astronomy and has the potential to make groundbreaking discoveries. And of course, your proposal has to be reviewed by other experts in the field. It's a tough process.
It sounds like the stakes are high.
They are. But that's how it is with cutting-edge science. The competition is tough because the potential rewards are huge.
So we know that distant galaxies and exoplanets are some of the hottest research areas. But what else are astronomers hoping to study with the JWST? What other mysteries are they trying to solve?
Well, one area that's getting a lot of attention is the study of the early universe. We're talking about the first few 100 million years after the Big Bang.
Wow, that's going way back. What are they hoping to find out about that era?
They're looking for clues about how the first stars and galaxies formed. How the universe went from this hot, dense soup of particles to the complex structures we see today. It's like trying to piece together the story of how everything began.
And how does the JWST help with that?
Because it can see in infrared, it can see through the dust and gas that blocks our view of the early universe. It's like having X-ray vision for space, allowing us to see things that were hidden before.
So it's not just about seeing farther out into space, it's about seeing farther back in time.
Exactly. That's what makes the JWST so revolutionary. It's giving us a whole new way to look at the universe and its history. We're really at the point where we might rewrite our understanding of how it all started.
This is all so exciting. It makes you realize how much we still don't know about the universe and our place in it.
I agree. We're really just at the beginning of this amazing journey of discovery, and the James Webb Space Telescope is leading the way.
Well, I think we've covered a lot of ground today. Maybe we should take a moment to let all of this sink in.
I agree. Let's take a short pause, and when we come back, we'll talk about what all of this means for our understanding of the universe.
It's funny, when we started, I just thought of the Sombrero Galaxy as that one famous picture, like almost a cliche. But now, wow, it feels like we've really explored a whole hidden world.
It really shows you what new technology can do. The James Webb Space Telescope, it's revealing so much that we never would have imagined.
It's like we went from just admiring a painting to actually walking around in the landscape it shows. And it's amazing. Even after everything we've learned about the sombreros, the dust, the stars, that quiet black hole, those ancient clusters, it still feels like we've barely scratched the surface.
Well, that's how science works, right? Every answer usually leads to even more questions. And the data from the JWST is so detailed, astronomers will be studying it for years. They'll keep finding new insights and connections.
So what are some of the big questions about the sombrero that scientists are still trying to figure out? What are they most puzzled by?
Well, one of the main ones is why the sombrero is forming stars so slowly, compared to other galaxies like our Milky Way. It seems to have everything it needs for active star formation, plenty of gas and dust, but it's not really using them very efficiently.
So any theories about why that might be?
One idea is that the supermassive black hole, even though it's pretty quiet, might still be affecting the gas around it. Maybe it's preventing the gas from collapsing and forming new stars.
Interesting.
Another possibility is that maybe the sombrero bumped into another galaxy sometime in the past.
Like a cosmic fender bender.
Yeah, exactly. Galaxies aren't just sitting still. They move around and interact with each other through gravity. And those interactions can have effects that last for a long time.
It's like a cosmic mystery, trying to figure out what happened to the sombrero and how it ended up the way it is now.
Right. And then there are those globular clusters. We talked about them being like time capsules. But we still have so much to learn about how they formed and how they've survived for so long. Like, why does the sombrero have so many more than other galaxies? How did they stay together for billions of years?
I'm guessing the JWST will help answer some of those questions.
Definitely. By looking at these clusters with so much detail, we can learn more about the conditions in the very early universe, how the first stars formed, how galaxies came together over time.
It's mind-blowing that we can study one galaxy and learn so much about the entire universe.
It really is. That's the power of astronomy. It connects us to something so much bigger than ourselves. It's a story that's been going on for billions of years.
It makes you wonder, what does all this tell us about our own galaxy, the Milky Way?
That's a great question. By studying other galaxies, we actually learn a lot about our own. The sombrero is a spiral galaxy, just like the Milky Way, but we see it from the side, which gives us a different perspective.
So it's like we're looking at a side view of a galaxy that might be similar in structure to ours.
Exactly. And by comparing what we see in the sombrero to the Milky Way, we can improve our understanding of how galaxies are built and how they change over time.
It's like looking in a mirror, but the image is kind of warped and distorted by time and distance.
That's a great way to describe it. And by studying that distorted reflection, we can learn more about ourselves.
So as we wrap up here, I keep thinking about how much our view of the sombrero has changed. It started as just a pretty picture, but now it's this dynamic, evolving system with a whole history and a ton of mysteries still to be solved.
And that's because we're willing to keep looking beyond what we already know, to push the limits of technology and expand our understanding.
And that's what makes it all so exciting. There's always more to discover, more to learn, more to be amazed by.
Absolutely. And as we keep exploring the universe with incredible tools like the James Webb Space Telescope, I have no doubt we're going to find even more amazing things. Stuff that will challenge our ideas and really spark our imaginations.
So for anyone listening who is totally fascinated by the Sombrero Galaxy now, what should they do to learn more?
Well, first of all, just look up that image, the James Webb image of the sombrero. Take some time to really look at the details. The dust, the central bulge, those amazing globular clusters, the faint glow of all those background galaxies. Just let your mind wander and think about everything that picture represents.
Yeah, it's like a portal to another world. A world that's both familiar and completely alien at the same time.
And if you really want to dig deeper, there's a ton of information online. Articles, videos, even scientific papers. But the most important thing is to never lose that sense of wonder.
That's the perfect way to end this. Keep exploring, keep asking questions, and keep looking up at the stars with a sense of awe and curiosity.
Because the universe is full of surprises. There's always something new to discover if we just look for it.